To build this origami serial manipulator, you are going to need the following materials: glue, super glue, pencil, liquid silicone, an Arduino board, a proto board, 20 jumper cables, 2 toothpicks, 1 needle, 1 sharp blade knife, 4 9-gram servo motors, a pair of scissors, a ruler, and a 1 by 0.7 meter bond paper sheet. The first step is to draw a 20 by 30 centimeter rectangle in the piece of sheet and cut it with a sharp blade knife. In this case, we're going to need two of these sheets of paper in order to fabricate the two first links of the robot. Once you've measured the square with the knife, try to be careful not to ruin your table by putting a magazine at the back, and cut the paper with a ruler. Any excess paper, you should cut it before folding the paper. The next step is to fold the paper in half by the long side, and after that try to make a small rectangle by any of the small sides. This rectangle should be 2 centimeters long, and it should be folded as many times as the paper allows it. After that, you should apply some glue in order to make sure that the link sticks like a rigid body, and you should fill any gaps formed by the layers of the paper. Be sure to press it firmly and let it dry for an hour or two. Once the two little pieces of papers are dry, you should use the servo motor to draw a rectangle on it and use the sharp blade knife to cut the rectangle. You should do this for every single layer of the link, and you do it for both links. Once you've removed all the layers of paper, you can mount your servo and give it a try to see if it fits. After that, you should try to stick the two screws in the little holes that come with the servo to attach it. If it doesn't fit, use the sharp blade knife to cut a little hole, and then use again the screws to make sure it fits. Mount on the other side of the link another hole with a screw and put it to a servo that is alone. We mounted it in a wooden base so it would stick it to so it would be easier to handle it. You can just glue it to another surface. Do the same thing for the other link and put it to the second servo. Now for the gripper, we're gonna make an origami shape. First of all, you need to start with an 8.5 by 11 centimeters piece of paper, fold it in half, unfold it back, then fold it the other way in half. Take the top right and left corners and bend it to form a triangular shape. Then with the bottom flaps, turn those upside on each side. After that, just push through the inside and to form a square. Fold each flap upwards to form a triangle by each side, as you can see in this part of the video. And after that, just push through the center and you form another square. Then pull each side of the square to form a little boat and put the sail inside any flap. Then just by the long side, push a little bit so you can form the gripper, and that's it. You got like a little Pac-Man. Take your little Pac-Man and put the toothpick inside of it and make two holes. After that, you can bend it and open it easily. After you got the toothpick, mount it to the hole of another servo and put some silicone to make one side of the mouth fixed. Leave it to dry for 3 hours, and that's it for now. After the mouth is dry, you should mount the gripper in the servo and use the needle to stick it through the moving side and try to cross it through the little white piece of plastic that comes with the servo. This should make the movement of opening and closing the gripper. After that, use some liquid silicone to make sure that the large toothpick is really, since this is a really complex movement, you should try to open and move the engine so you can be sure where you can make the toothpick stay still according to how big is your gripper. In this case, I close the mouth. Let's say put the servo in zero in the initial position. The next step is to connect digital pins 2 through 5 to the proto board and connect the 5V connection to one side of the proto board and the ground connection to the other side. After that, we can connect the servos in order from 2 through 5 to the proto board and that to the Arduino, and that should be all for the connections you have to do. If you need so, you can use a lighter to remove the plastic that covers each cable. The diagram of the circuit is shown in the comments section below, so you can make it without using this video. After that, the next step is to grab a little bit of super glue and attach it to the base of a servo to make the mouth move, the last servo. That's pretty much it. You should mount the last servo to to the second link, and you should now be able to try to move every degree of freedom that it's on the servo. The next step is connect the computer and just power each motor and see if everything is running smoothly. You should check that every single servo is mounted on 0 degrees, so you can control it with a code that it's also in the comment section below. The next step is to show some tests that we made to the robot. We move the mouth to check if it can hold on a little eraser. It made it without any effort. Then we tried to move the base of the robot, and after that we tested each degree of freedom individually. This video shows different examples using articular variables, although the program is also made to use inverse kinematics, so you can solve any problem you would like.